So now see here, in this problem what we see, a hollow steel tube is to be used for carrying an axial compressive load of 140 kilonewton. The yield stress for steel is 250 Newton per millimeter square. He gives me sigma y. A design factor of 1.75 is used. He already give you factor of safety. Okay. Now he is having three different sizes. He is asking us which size you will select. That's all. Okay. He is asking me which size you will select. Okay. So one is what? One is the outside diameter is how much? Outside diameter is, let me first draw three tubes first. I have one tube, 105. This is outside diameter, 101.6. What is the thickness? 3.65, is it not? So let me draw all the three tubes. I got it anyway. We thought it was hanging. This is another one, and this is another one. So one tube is what? It is very thin, and in the other tube is little bit thick. The third tube is really thick. This is what he says. Okay. So outside diameter is how much? Outside diameter is 101 in all the cases. This is 101.6, right? 0.6, yeah. This is also 101.6. This is also 101.6. So in the first case, the thickness is how much? 3.65, correct? So please subtract 101.6 minus itna in marra 3.65. So then what we will have the inside diameter? How much? 94.5. Okay, in the second case, 101.6, now is itna in marra 4.05. 93 point. In the third case, 101.6 nages itne in marra 4.85. 91 point millimeter square, correct? So these are the three tubes he is having. Okay. Now I need to find out what? I need to find out area of cross section. But what is the area of the tube now? Area of the tube is area is equal to pi by 4 into d outside square minus d inside square. This is the formula, is it not? Correct. So now here you find out how much? Pi by 4 into 101.6 nages 9 square nages 94.5 square here. For the second one, pi by 4 into 101.6 square nages 93.5 square. And for the third one, pi by 4 into 101.6 square nages 91.9 square. Please tell me the values here. هذا أول 10.5 millimeter square. Okay. For the second one, do it fast because my laptop battery is finishing. Where is your hand? You use the calculator. When you have a calculator in your hand and you are sitting comfortably, somebody will do the job for you. How much, Herbie? Huh? So, everyone is telling a different answer. Is it correct? 1241.17 millimeter square, is it not? Okay. For the last one, huh? How much? 1474.2 millimeter square. You can even forget it. Okay. So now you have got these three different areas, right, Shivan? You have these three different areas. So you have light, you have medium, and you have heavy tubes. He is asking us what? He is asking us which type you are going, which tube you are going to use. Now let me see. Uh, what shall I see? 140 kilonewton is the load applied, compressive load, is it not? The yield stress is how much? 250. So what is the factor of 50 I will take? I will take n is equal to how much? Take n is equal to 2. Therefore, your design stress will be equal to how much? What he has given in the problem for us, he has given 140 kilonewton is the load, is it not? And the yield stress is how much? 250 Newton. This one, not 1093. See, this is the trouble, yeah. You have to give me correct answer because it is getting recorded. Please check. The 101.6 square minus 94.5 square multiplied by pi divided by 1093 is the correct answer. Okay, fine. Anyway, so 250 is the yield stress. So what can I do here now? I can go sigma design is equal to sigma yield by 2, that is 250 divided by 2, that is 125 Newton per millimeter square. This is your design stress. Okay, Shaman? Okay. So now you know the areas. What he wants now, he has given me the value of force also, correct? What is the value of force? A design factor of 1.7, oh sorry, 1.75 he has used. I made a mistake here. 1 minute. I took it as 2. Please remove this. Please remove, what is this here? Okay. So what will be this value, I think? Please tell me. This is 1.75 he gives. How much is this value? 142.9, huh? 142.9 and 143. Okay, Newton per millimeter square he has given. So now what he wants is now the following three types of tubes are used. Which tube you will use? This is what he is asking me. Okay. Now I simply see if the best is not to use the heavy tube, is it not? If you are using heavy tube, you are giving more money, correct, Shivam? You are giving more money, is it not? I will not do that. What I will do is I will divide force by area. Okay, Shivam, and I will see if my stress is not crossing 100 and how much was that? 143 megapascal. If it is not crossing, that's okay for me. Why should I go for a heavy tube, right? Clear now. So what I will do now, I will simply say, I will find out stress. Stress is what? Stress is equal to force by area. Is it not? What is my force? How much he has given me in the problem? Please tell me. 140 kilonewton. Is it not? Let me go for 140 into 10 cube. Be careful. Okay. Divided by area. What is the value of area? Can somebody tell me? Because I cannot see it. 10. The first one. Where is that? 1093.5, right? Let me just see. 1 minute. 1093.5. How much is this value? 128 Newton per millimeter square. Excellent, yeah. This is enough for me. My stress, even with a thin tube, light tube, is only 128. But what is allowable allowable is 143, is it not? So I will say since since sigma is equal to 128, which is less than 143 Newton per millimeter square, we will use light tube, is it not? Of thickness. How much is the thickness? Let's go back and check what is the thickness. 3.65 millimeter. Okay. Clear now? Not necessary you should use the thick tube. Thin tube is okay for me because it's meeting my purpose. Even with factor of safety, my allowable stress is how much? 143 megapascal. I am having 128, which is less than 123. So it's okay for me. Clear now? So like this, you have to just do it.